These are notes 4.6 for Algebra 1, Solving Systems of Equations by Elimination, Day 1. So you already learned how to solve using substitution. And substitution, as well as elimination, the thing to remember is that when you have two or more variables in your equations, you can only solve for one at a time. So when we substituted, we took away one of the variables and only solved for x or only solved for y. We're going to do the same thing with elimination. You want to get so that you're only solving for one variable. And so the first thing we're going to do is this call out box right here. Let's put some notes on what the steps are, and then I'm going to go through it with you so you can see how it works. Okay, so here are your steps. Step 1, combine the two equations so that one of the variables is eliminated. It becomes a zero pair and disappears. Step 2, solve for the variable that remains. So if you eliminate x, then you're going to solve for y, or vice versa. Step 3, plug the answer for the first variable, the one that you just solved for, back into one of the equations and solve for the other variable. And then the solution should be written as an ordered pair, x comma y. And then I'm going to add a final step that you should check your answer in the original equation. So I'm going to go through number 1 and show you what we mean by doing this by elimination rather than substitution. So I just took these two equations and I rewrote them. I haven't changed anything. I rewrote them here. And I want you to notice that right here on the upper equation we have minus y, and on the lower equation we have plus y. So if I were to combine these two equations, that is add them together, this y is going to be eliminated. So let's go ahead and do that. We're going to add the two equations. So 3x plus minus 2x is going to be 1x is left. The y's cancel out, and negative 2 plus 3 is 1. So now I know that x equals 1. So we've solved for one of the variables. Okay, now our next step is to plug the answer for the first variable back into one of the equations and solve for the other one. So since now that I know x is 1, I'm going to plug that back into one of the equations. It doesn't matter which equation you use. So I'm going to go ahead and use the bottom equation, this one. You could use the upper one. It'll do the same thing. So I'm going to rewrite that equation. Okay, so I rewrote the equation, and now I'm going to take the equation and I'm going to put a 1 in for x. Leave everything else the same. So now I have negative 2 plus y. Negative 2 plus y equals 3. I'm going to add 2 to both sides, and so y equals 5. So the ordered pair for this solution is 1 is x and 5 is y. So 1 comma 5. There's our answer. Now, as I mentioned previously, I think you should check to make sure the answer comes out true. So I'm going to use the other equation to try it. I'm going to use 3x minus y equals negative 2. So 3x minus y equals negative 2. And I'm going to put 1 in for x, and I'm going to put 5 in for y, and we're going to see if that comes out to negative 2. So 3 minus 5 is equal to negative 2, so we get negative 2 is equal to negative 2. It works. Okay, so I do highly recommend you check your work. Okay, let's go on to number 2. Okay, the second question says the sewer gator baby. So apparently there's a gator in our sewer system that's having babies. Travels through the tunnels modeled by these two equations. Solve the system of equations to determine the best place to trap the sewer gator baby. Okay, so without the graph, that just is meaningless. Basically, we just need to solve this equation. So when we look at the two equations, you can see that there's a plus y and a plus y right here. Well, if I were to combine these two equations, Nothing would get eliminated. So what I'm going to do is I'm going to take this second equation and I'm going to multiply everything, both sides, by -1. So I'm going to go ahead and take the first equation and write it up here. 4x plus y equals 17. And now I'm going to multiply by -1, so I have -x minus y equals -5. Now when I combine these two equations, adding them together, we are going to eliminate the y. So 4x minus y, or 4x minus 1x is 3x. These cancel out, and 17 minus 5 is 12. Now we divide by 3, and we get x equals 4. So there's our x variable. So now we're going to take that variable and we're going to plug it back into one of the equations. And again, it doesn't matter which one you use. I always look and say which one looks easier to me, and that's the one I pick. So I'm going to use x plus y, the original one that says x plus y equals 5. And so I'm going to plug 4 in for x, and now we subtract 4, and we get y equals 1. So our ordered pair for this set of equations, system of equations, is 4, 1. There's our answer. Now, as always, let's check. I'm going to use the other equation, 4x plus y equals 17, and make sure it works. So I'm going to plug 4 in for x. I'm going to plug 1 in for y. And we get 16 plus 1, which is 17. 17 equals 17. It checks. Okay, bada bing, bada boom. Let's go on to number 3. Okay, so question 3 says, Julie went to the Texas Tornado hockey game and bought 2 hamburgers and 2 Cokes for $5.36. Angela bought 3 hamburgers and 2 Cokes for $6.85. What is the cost of 1 hamburger? So it shows us to write let statements. So I am going to let H equal hamburgers. And I'm going to let C equal Cokes. And not just Cokes, this would be the cost of the hamburgers and the cost of the Cokes. Because that's what we're looking for here, the cost of one of the hamburgers. Okay, so let's come up with 2 equations. This should not be too difficult because it tells us 2 hamburgers and 2 Cokes for $5.36. So we're going to say 2H plus 2C equals $5.36. Now let's look at what Angela bought. She bought 3 hamburgers and 2 Cokes, and hers cost $6.85. Now, again, we need to look the equations over and ask ourselves, what can we do to make one of these variables eliminate? So when I have 2 equations like this, I like to look for the one that has the smaller of the 2 variables, the smaller coefficients, and that's the one I like to multiply by -1. I'm going to take this upper equation, I'm going to multiply it by -1, because if I do that, I'll end up with minus 2c right here, and I'll end up with plus 2c right here, and those will get eliminated. So to start this off, I'm going to take this equation, I'm going to put it on top, 3h plus 2c equals 685. And now the one that I'm multiplying by -1, I get minus 2h minus 2c equals negative 536. Now, let's combine those 2 equations, and we end up with h, these cancel out, is equal to $1.49. So we can write here in the little call-out box, a hamburger Or maybe it would be better to say one hamburger. One hamburger costs $1.49. Now, I went ahead and solved this equation. I took the $1.49 and I plugged it back into the original equation, and I found out that a Coke costs $1.19. And then I took those two amounts and I plugged them back into one equation to make sure they check, and they do. So there you go. Okay, let's look at number 4. Now, I would like you to think about what you've learned in the first 3 questions and see if you can do number 4 and 5 by yourself. So hit pause now and give it a try and see if you come out with the same thing that I do. Okay, for number 4, you don't have to multiply by anything, just combine your 2 equations, and when you do that, these y's right here in the middle eliminate, plus 2y minus 2y. So you get 4x equals 6, divide by 4, and x equals 6 over 4, or 1.5. So now I took this 1.5 and I plugged it in for x in the other equation. So here's my other equation, 3x plus 2y equals 5. And you get 4.5 plus 2y equals 5. Subtract 4.5, 2y equals 0.5. Divide by 2, y equals 0.25, or 25/100. So here's your ordered pair. Okay, now you should have tried number 5 as well, so let's see how you did on that. Okay, so for this one, I got the ordered pair, 13 over 5, comma 6. Now let's see how I did that. When you look at your 2 equations right here, if you combine them, the x's are going to eliminate. Okay, so plus 3y minus 2y is y, and 5 plus 1 is 6. So there's our first variable, y equals 6. So then I plug that in for y in the second equation, 5x minus 2y equals 1. And I solved that out and got down here to 5x equals 13, and divide by 5 and you get x equals 13 over 5. So right here in this blue area, this is where I'm checking my work. So I have 5x minus 2y equals 1. So I put 5 parentheses 13 over 5 minus 2 times 6 equals 1. Well, hey, when you multiply by 5 and divide by 5 on the same with the same number, they cancel each other out. So I'm left with 13, and then negative 2 times 6 minus 12 equals 1. So 1 equals 1. It checks. Okay? I hope you're catching on. Let's go to the back. Haha! So number 6 is a challenge question. So you need to try this yourself and bring it to class tomorrow. I think I'll give you a little hint. Hint. Multiply one of the equations by -1 and see how you do. See you in class.